Hey guys, I'm back with a new video. In the previous video, we'll learn about the for each method using which we can transform the array of games to play using the for each method. We picked up each game string as you can see here. So for each game, what we did was we took the game and basically concatenated a string outdated to it, to each of the games that we had in the array, where of course each game mutated and also the original array got mutated as well. So in this video, let us learn about the map method and reduce methods to work with the arrays. So if you haven't checked out the ongoing series yet, I would highly recommend you to bookmark the playlist so that this playlist becomes yours and you can easily refer it as and when required. To keep our original array in touch and get the absolute new copy of the array, we can make use of the map method and don't mutate the original source of data. So what I will do is I will create a new constant and I will name it as games to copy, games to play copy, games to play dot map, and this will take a callback function. Inside the callback function, I will pass the game that we are currently on. So I will say game, the index, which is an optional argument, and then the array of games if it is required. And then I will return a new game, which is the transformed version of the game we had. For each game that is there in the array, as you can see, Call of Duty, what I will do is I will pick the game and I will concatenate a string outdated to it. And this we will do for each of the games that is there in your games to play array. And now after performing this map operation, I will log the games to play copy to the console. So now we are working with a copy and not the original array. So we are directly making a copy of it. So whatever output we have now is the transformed version of the original array, but we are not mutating the original array. We are just transforming it and not on the original array. We are just transforming it and mapping that to some other array. Okay. So this will return a brand new array and we are not working on the original array. We are just making, first what we are doing is we are just cloning the array. We got a copy of it and now we are working on the copy. As simple as that. So if I log games to play to copy to the console and add a mutation to it, so basically I push some element to it, like say changed, and log. Okay, so I'm directly applying a mutation to the copy, and if I log games to play copy to the console, you will see the change, the mutation that we are doing now will only change the copy and not the original array. So let us see that in the output. So as you can see, this is our copy and this is not the original array. This is the copy of games to play. Okay. And now if I log the games to play to the console, you will see that the changes will not be reflected there. Okay, so let me reload. Okay, so as you can see, no changes here. The array stays intact. So back in my Visual Studio Code, let us see more on map method. Now, if as on logging the games to play copy to the console, you're getting the exact same output, but this time it is managed using a separate new array instead of directly mutating the original array, which in this case is games to play. So we are not mutating the original array, we just made a copy of it and we are working with the copy and not the original array. Okay, so I hope it makes sense. Now this new array games to play copy is actually sitting at altogether a different address in memory than the one at which games to play is sitting. So these two locations in memory are different. The array that we got back using map method is a transformed version and it's just giving a copy of the original array, which was games to play. And then we have mutated the copy only, which is the games to play copy and not the original array games to play. Now there is another method that you should definitely know as well, which is the reduce method. Now this method is a bit different from the ones that we learned in the previous videos. Let us understand it from practical standpoint. So reduce method, what I will do is I will define an array of marks. So I will say student marks out of 100 per subject to give it a more descriptive name. Okay, so I'm using student marks out of 100 per subject as the name, and I'll pass here some bunch of marks. So I will say 56.2, 98.8, 67.2, 33.4, 44.4 and 100. Now what I now want to do is I want to calculate the percentage of marks using the for each method first, and then we will see how we can easily do this using the reduce method as well. So what I will do is I will create a variable and name it as let total marks, set that to 0, and I will say student marks out of 100 per subject for each mark that is there in this array, for each student mark. So I can say subject marks. So in the very first iteration we will be getting this 56.2 as the current value that we will be working with, which is subject marks. And what I will do is I'll basically add that to our total marks, and I will say subject marks, and in the end I will log the total marks to the console. So what is happening in this case is first we will get the value 56.2 and we'll add that to our total marks. In the second iteration we'll get 98.8, add that to total marks, and in the end once the iteration for the complete array is done we'll get the total marks. So let me check the output in the browser. So now you can see we are getting 400 in our browser console. So this is how we can basically get the total marks. But this is not my intended output. I want to get the percentage of marks secured by the student. To get the percentage of marks secured by the student, so as you can see from the given array, we are having marks of 6 subjects for a particular student. So to find out the percentage marks secured, I will make use of the formula. So what I will do is, I will define a new constant and I will name it as percentage secured, and I will say total marks, divide that by 6, and then whatever we get I will divide that by 100, and then I will multiply the result by 100. And what I will now do is I will log the percentage secured to the console. So console log percentage secured, and let me check the browser output. So back in my browser you can see we are getting 66.66% for the student. Okay, so this is how we can achieve this using the for each method. Now the approach that we use above is not problematic by any means, but of course we can do better. So let us see the reduce method in action.